Imagine that we have just obtained a model fit to single-dose data. A very common modeling objective is to use the model parameter values to simulate repeat dosing, allowing us to predict the concentrations that will be obtained at steady state. In this video, we will show you a simple way to create these simulations. One way to simulate the repeat dosing would be to create a worksheet with all the time and dose values with a row for each individual dose. However, if you want to modify the dosing regimen, you have to change a lot of values in this worksheet. Therefore, this is the hard way to do it. There is a much easier way. We only need to have one row for the initial dose at time 0. We add a column called ADDL, which is the number of additional doses and the dosing interval. These two approaches would result in exactly the same doses, but the approach on the right is much easier to set up. We start with a similar worksheet with columns for the dose amount, the number of additional doses, and the dosing interval. We also included an empty COBS column. This column is not necessary, but it is useful to include for reasons we will show later. We will start by sending the worksheet to a Phoenix model. We have set the model structure to match results from prior studies. Several of the columns are mapped automatically, because the column names match the mappings. Mapping an empty COBS column eliminates a message that there are no observations mapped. Now, if we see a warning here, it is likely to be more important. We will also map regimen to sort. It is not needed at the moment, but it will help later. Let's select the Parameters tab so we can specify the parameters to use in the simulation. We will enter the parameters on the Fixed Effects sub-tab. By default, the parameter estimates are all equal to 1. And here we have entered the parameter values obtained from a previous model. Let's go to the Input Options tab, which is where we will enter the multiple dosing information. We will turn on the ADDL checkbox. Now we will select the Add button. First, we will specify the time interval. This can either be a constant or a column in the worksheet. Let's toggle it to column. The column with the delta time is called II in our worksheet. Next, we need to enter the name of the dose point, which is AA. The dose can either be a bolus or an infusion. Because the dose is added all at once to the AA compartment, the bolus option is correct for this simulation. For the dose amount, we will change it to column. And then enter the column name in the text box. Make sure you enter the name of the dose point and the name of the amount column in the appropriate boxes. In our case, they are both called AA, but this may not be the case for other examples. Next, we will go to the Run Options tab. Let's put it in simulation mode. The simulation settings have already been filled in. A total of 1,000 points over a range of 400 hours, and reporting the variable uppercase C, which is the concentration in the central compartment. We are now ready to execute the Phoenix model. The output is in the individual simulation plot. And here are the results of the simulation, reaching steady state by about the 7th dose. This approach can easily be extended to additional dosing regimens. Here we have added a second row to the input worksheet. This new row adds a regimen called BID, and it has a dose amount of 2,500 micrograms, with 27 additional doses, administered at 12-hour intervals. After adding this row, all we have to do is to re-execute the simulation. Here is the plot that results, with both the BID and QD regimens. Both simulations predict the same average steady-state concentration because they have the same daily dose, but the QD dosing results in wider concentration swings. Just remember the ADDL input option the next time you need to do a multiple dose simulation.